Hello, welcome back into it. So today we're just gonna use all the tricks that we have learned on trigonometry to solve, actually to prove whether the left hand side is equal to the right hand side, and as well solve for x, which will lead us to general solution. So yeah, before we start, let's just remind each other of the important things that we need to note of. The first one is that okay. The first one is that tan of any angle, let's just say tan theta is equals to sine over cos. Another thing that we need to know is that cos squared theta minus sine squared theta will give us cos 2 theta, the double angle. As well, we know that 2 sine theta times cos theta will give us the sine 2 theta, double angle as well. And we know that sine squared theta plus cos squared theta give us what? 1. What else do we need to know? I think that's it. And then from then we can go about proving now. Let's just give a different color so that whenever we prove, let's say we're given an case study, an activity here whether we have 2x sine 2x minus sine x all divided by cos 2x plus cos x. This gives us what? They say it must be equals to sine x all over cos x plus 1. So this is when we are proving. In most cases, they're just going to give us the left and the right hand side. Then from you choose which side you want to simplify until it's similar to the other side. If it's not similar and you are sure that you did everything correct, then you can conclude by saying right hand side is not equals to left hand side. But if you simplified maybe the left hand side and it leads you to the right hand side as well, you can conclude and say the right hand side is equals to the left hand side. It's all up to you how you end up with. So in some cases, but it's rare for this one to occur. It's very rare because they can't just make you prove something that doesn't exist, right? So let's start with this one and continue with this one and see. So another tip here is that always take the side that looks complicated and make it to the simpler side, because you see sine x, there's no relationship here that there's only sine x, but there's a relationship where you have sine squared, so it's easier to take this side. Then we're going to take the left hand side, which is equals to sine 2x minus sine x all divided by cos 2x plus cos x. So by all means, we're just going to make this equals to prove that is equals to the right hand side. Then since you can see that this is the sine 2x, we can just replace sine 2x with this, whereby we're going to have 2 sine x cos x minus sine is just sine x here, this one, divide by 2 cos 2 sine, it leads us to this one, to this here, and then we're just going to replace it as well, minus sine x squared and then plus cos x. And remember, we're trying to make this look like that. So at the top you must only be left with sine. Here you must have cos plus 1. Then you can clearly see above, this one has sine x and this one has sine x. Then above we can factorize by common factor by taking sine x outside. Then it's left with 2 cos x, these 2 and this cos, minus 1, because if you're taking sine x out, you're only going to be left with 1 there. All divide by here at the bottom. We don't want sine x squared, but we know that sine x squared is this. From here you can make sine x squared sort of the formula by taking this to the other side. Then your sine squared theta becomes 1 minus cos squared theta, just making this subject of the formula. Then we replace that here. We have 2 cos x minus into brackets 1 minus cos squared theta, and then plus this cos x. Then from here we simplify the bottom part. The upper part we just copy it the way it is, minus 1 all over. This becomes cos squared. This becomes another cos squared. Then it becomes 2 cos squared, and then you have plus cos x and minus 1. Alright, so in most cases we are just using factorization, but we have to be conscious of it. Look at this, the bottom part, right? The bottom part can be written as 2x squared plus x minus 1 if you let x be equals to cos x. Wherever you see cos x on this, you put x, then you're going to be left with this, and this can be simplified or factorized into 1 and 1, because factors of 1 is just 1, and then 2x and x. Right, this will be plus and this will be minus. Then you replace the cos again. Then the bottom part, it can just be replaced by that 2 cos x minus 1 all divided by into 2. We take the very same x you've let put it again, then this becomes 2 cos x minus 1 bracket, and then this becomes cos x plus 1 bracket. But look at this, this is 2 cos x minus 1, this is 2 cos x minus 1, these are multiplying there, so all multiplying, so this and this becomes 1, indirectly cancels out. Then you are only left with sine x above. Below you are left with this bracket, which is cos x plus 1, and this is equals to that. Then you can just say it's equals to the right hand side. Then you agree that left hand side is equals to the right hand side. That's how we do it. As easy as that, right? You can quickly do another one whereby they say 1 minus cos 2x divided by sine 2x. This must give you tan what? Tan x. Right? Sharp. So you take the left hand side, you just say the left hand side as it is, minus 1 cos. Why the left hand side? Because this can be changed. You cannot change tan to the other way around. You just have to change the left hand side. But it's not a norm that you must always take the left hand side. You can take the right hand side and prove otherwise. Depends which one it's more simplifiable than the other. Then here you're just gonna be 1 into cos 2. You know cos 2 is this one. Then it's going to be into cos squared minus sine squared. All divided by what? Sine 2 is going to be 2 sine theta or x. Yo, I'm using theta while I'm using x, but still the same. And then cos theta 2, right? And remember, you're looking for tan, and you know that tan is sine over cos, is sine over cos. So what we have to do is that on top it must be left with sine, and at the bottom we are left with cos. Then this we can complete and say it's equals to tan. Sharp. I will leave it here for you to continue with it, so that I move over to the general solution part, because I haven't touched it and I'm running out of time. Yes, the general solution part. The general solution is simply solving for x, solve for the angle, solve for the angle. The angle is called reference point. Reference, not reference point, reference angle. Once you have the reference angle with sine trig ratio, what will happen is that you're going to take your reference angle and say plus k times 360 degrees, where k is the element of real integers. And then again take the reference, say 180 minus the reference angle, and then say plus k 360 degrees, where k is the element of the integers. This will be your conclusion at the end with sine. And then with cos, your conclusion will be the reference point must either be plus or minus plus k, where k times 360 degrees, where k is the element of the integers. So you see you have 1, 2 answers for sine, you have 1, 2 for cos. And then for tan as well, you just have to have, you only have one, whereby it's a reference angle plus k, no longer times 360 plus 180 degrees, because with a tan function you have asymptotes. Great. So I'm just going to show you where this is important. Let's say for now you have, as an example, as an activity, you have 2 cos x squared plus cos minus 1 is equals to 0. Similarly with what we did here, you can see that this can be written as what? 2, let's say y squared plus y minus 1, where you let y is equals to cos of x, meaning wherever you see y, you just put cos of x, then it's going to take you here. Then let's factorize this. You're going to be left with 2 this sides, with 2y, y, 1 and 1, positive and minus. Then this thing, it goes to be factorized into 2 cos x minus 1 into cos x plus 1, then it's equals to 0. While solving for x, we know that this bracket must be 0 or this bracket must be 0. Then you are left with 2 cos x is equals to minus 1 is equals to 0, or cos x plus 1 is equals to 0. Then you go about saying cos x is equals to negative, the other side becomes positive 1 all over 2 divided by this 2. And then this side you get cos x is equals to negative 1. Then you know your x this side is going to be cos minus 1 into negative 1. Then this becomes what? You can simply do it to minus 1. It becomes 180 degrees, right? And then this one where you take cos to the other side, it's going to be cos minus 1 into 1 over 2. Then your x this side, it's what? You can just do it quickly. It becomes your 60 degrees. So what? This is your reference angle. As well, this is your reference angle. And then in conclusion for this only, you're just going to say x is equals to your reference angle 60 degrees. And then you're going to say plus or minus. Why? Because we are using cos. We're going to conclude with this plus 60k 360 times k, where k is the element of z. Then this is your conclusion. You have your two answers. The other one is minus, the other one is positive. Same with this one, we can just say x is equals to plus or minus 180 degrees, because 180 is your reference angle, plus k times 360 degrees, where k is the element of z. Right? Sharp, because we are using this, because this side is cos, even this side is cos. Then you have your four answers. Negative 180 plus this, positive 180 plus this, negative 60 plus that, positive 60 plus that. I hope everybody understands until this point. If not, I can make another videos on this to emphasize the point, but this will be enough for today. Thank you so much. Keep watching. See you next time.